Welcome back to Statistics Made Simple, and I am Savita Balsang. In this video, Solutions to Problems on Probability Part 5, I'll continue with problems on playing cards. Problem 19. Find the probability that 3 cards drawn at random from a pack of playing cards belong to the same suit. Solution: write given total cards is equal to 52. Now in the problem they mentioned that 3 cards are drawn at random. So the possibilities are n equal to 52C3, which is equal to 22,100. Define event A as 3 cards belong to the same suit. Now how do we interpret this statement? 3 cards belong to the same suit. It means we can either have 3 spades or 3 clubs or 3 hearts or 3 diamonds, as I have mentioned within brackets. And or is important over here. It is highlighted in red color. And remember that or, the mathematical symbol is plus in probability. So m is equal to, let's do 3 spades. There are 13 spades and you have to choose 3 spades. So the different possibilities are 13C3. Then or means plus. Similarly, we have to choose 3 clubs. There are 13 clubs and you have to choose 3. So it is 13C3. In a similar way, you have to do it for 3 hearts and for 3 diamonds. So you will get again plus 13C3 plus 13C3. Therefore, m is equal to 286 plus 286 plus 286 plus 286, which is equal to 1144. Then write the formula. We know that P of A is equal to m divided by n, which implies P of A is equal to 1144 divided by 22,100. Therefore, P of A is equal to 0.0518. Problem 20. 2 cards are drawn from a well-shuffled pack of playing cards. Find the probability that first subdivision both are spades, second subdivision both are kings, third subdivision one is a spade and the other is a heart, fourth subdivision cards belong to the same suit, the fifth subdivision cards belong to different suits. Solution: given total cards is equal to 52, that is n is equal to 52C2, which is equal to 1326. Start with subdivision A. Define event A as both cards are spades. We know that the total number of spades are 13 and out of them we have to choose 2 cards which are spades. So m is equal to 13C2, which is equal to 78. Then write the formula. We know that P of A is equal to m by n, which implies P of A is 78 by 1326. Therefore, P of A is equal to 0.0588. Division B. Define event B as both cards are kings. So m is equal to, we know that there are 4 kings and out of 4 kings we have to choose 2 kings. So it is 4C2, which is equal to 6. Then we know that P of B is equal to m by n, which implies P of B is equal to 6 divided by 1326. Therefore, P of B is equal to 0.0045. Third subdivision. Define event C as one card is a spade and the other is a heart. Let us do the first part. One card is a spade. That means m is equal to, there are 13 spades and you have to choose one. So it is 13C1 and means it is into. The other is a heart. There are 13 hearts and you have to choose one. So it is 13C1. Therefore, m is equal to 13 into 13, which is equal to 169. Then we know that P of C is m by n, which implies P of C is equal to 169 divided by 1326. Therefore, P of C is equal to 0.1275. Fourth subdivision. Define event D as both cards belong to the same suit. Now both cards belong to the same suit means you have to pick either two spades or two clubs or two hearts or two diamonds. So M is equal to, there are 13 spades and you have to select 2, so 13C2 or is plus. In a similar way, there are 13 clubs, 13 hearts, 13 diamonds, out of which you have to choose 2 cards each. So you get M equal to 13C2 plus 13C2 plus 13C2 plus 13C2. Therefore, M is equal to 78, which is added 4 times, which gives us 312. We know that P of D is equal to M divided by N, which implies P of D is equal to 312 divided by 1326. Therefore, P of D is equal to 0.2353. Fifth subdivision, define event E as both cards belong to different suits. Now note that events D and E are complementary events. Recollect that event D was both cards belong to the same suit, and now we have event E as both cards belong to different suits. So D and E are complementary events, and we apply the complementary probability formula, which is P of A dash is equal to 1 minus P of A, and in this case we'll have P of E is equal to 1 minus P of D, which is equal to 1 minus 0.2353. Therefore, P of E is equal to 0.7647. Problem 21. What is the probability that 4 cards drawn from a well-shuffled pack of playing cards belong to different suits? So remember that different suits means it will be one of each suit. Solution, given total cards is equal to 52, that is N is equal to 52C4, which is equal to 2,70,725. Define event A as 4 cards belong to different suits. That means it is one card of each suit. So within brackets I have specified that it is one spade and one club and one heart and one diamond. And here and in probability means multiplication. So M is equal to 1 spade. There are 13 spades and you have to choose one. So it is 13C1 and is into. In a similar way, we know that there are 13 clubs, 13 hearts and 13 diamonds, out of which you have to choose one club, one heart and one diamond. So you get into 13C1 into 13C1 into 13C1. Therefore, M is equal to 13, which is multiplied 4 times, and you get 28,561. We know the probability formula is P of A is equal to M by N, which implies P of A is 28,561 divided by 2,70,725. Therefore, P of A is equal to 0.1055. Thank you all for watching, and look out for my next video where I'll explain addition theorem of probability for 2 non-mutually exclusive events and for 2 mutually exclusive events.